Okay, so hope everybody had a good 3-day weekend. But a few things I want to go ahead and talk about. First, on Thursday, you've got your next major exam. Enzo, please take that out. Thank you. Uh, Keep it out. Okay. You've got your first, or should be second major exam coming up on Thursday. This is going to be really important to a lot of folks because next Friday is the end of the 6 weeks. You're going to have a lot of grades left. Several, in fact, because of the happy minutes. Those could really help you out, as can the test grade, but it can also hurt you at the same time. So please be, practicing, look over the homework. I'm going to talk to you in just a few moments about what the next set of happy minutes is going to be. But as far as the test goes, if you go to the website, okay, I uploaded it just today. There's a blank unit circle if you're wanting to get a little more practice on that. But trig functions, evaluating, and reference angle practice. Reference angles and being able to evaluate a trig function are a major part of this exam. So I put these extra problems on here and the answers are included. Okay, so you still have a couple of days to look those over. If you have any questions, please come on in. The thing about the website, we are almost done with the second 6 weeks, so we're about a third of the way through the school year. And not everyone, but I'm still having a decent number of people not going to the website, coming on in, saying, hey, I need everything that I missed. What did we miss while I was gone? All this good stuff. And at this point, guys, if you're not going to the website, you're not following expectations. Okay? If you're absent, you are expected to go to that website. Now, I do have whatever additional copies over on the door over there in the top 5 pockets listed by day. But, at this point, if the people who come in continue to say, hey, I haven't bothered to go to the website, I need you to give me everything that I missed, I'm just not going to deal with those people anymore, okay? Because you are choosing not to go to that website. You are choosing not to follow expectations. I'll still try to help you out, but I'm not going to put you over another student who is actually coming in and trying to get things taken care of. So please be aware of that, guys. We're this far into the school year, so we should be going to the website. If you're not, that is your choice, not mine. Okay? I am always encouraging you to go to that website. All right. With the end of the 6 weeks coming up, I do have an extra credit option now. This is extra credit. If you don't want to do this, you don't have to. Some people may want to consider doing this. You're going to have a week to do it. It's going to be due on Tuesday. This is a poster project for the unit circle. Okay, it has to be done on poster board, only on one side, not both. You're going to go ahead and draw the unit circle. You're going to draw one larger than the others. It has to include all 3 parts, the degrees, the radians, and the coordinates. And then you're going to go ahead and draw 5 other circles, but you don't have to fill those in completely. You're going to choose some additional points, in fact 5 additional points, and you're going to show me through triangles how we first looked at the unit circle, how you derive those coordinates. Okay, so if you're not quite sure what I'm referring to, let's take a look. This is one of the sheets you picked up today. All right, so this point that we're talking about right here, what degree measure is this? That's 135 degrees, 3 pi over 4. So that point, unfortunately, you can't use because this one has already been used as an example for you. So this is one of the additional 5 that you're going to do. You don't have to fill in the unit circle on this one because you're only interested in one point. You're going to connect that point perpendicular to the x-axis with a triangle. You're going to identify it as the 30, 60, 90 or the 45, 45, 90. And basically, you're going to walk the reader through how you got that point. Okay, based on the radius of 1. Now, I don't think it needs to be a novel like this right here. The example that's provided, I would definitely say that's overkill. But there's also an example I've got showing up where the student didn't go far enough. So you kind of want a happy medium. But is everybody okay with what I'm talking about as far as the additional 5 circles? So you have 11 other points to choose from. You can't choose a quadrantal. Can't be an axis. So it has to be one of these 11 remaining points in the quadrants. Okay. Well, the rubric is provided, so you're going to know exactly what I'm going to be looking for. So you should be able to determine exactly what your grade is going to be. And I am going to record this as a test grade. Okay. Now, normally we only have 2 tests per 6 weeks. The category is 30%, so each of them are 15% each. They are your largest grades for the 6 weeks. But if you go ahead and do this, then you're going to have 3 tests, and one of them hopefully would be really good, and they're only going to count for 10% each. So maybe if the first exam or even the second exam is a little lower than we would like, it wouldn't count as much because we also have this. So I'll kind of let you decide, if you want to do that or not. But you'll notice the first 4 boxes, the main unit circle covers most of the poster board. Just draw in the unit circle, and it has degrees, radians, and the coordinates. Those are the first 4 boxes. Okay. You want to make sure that you have all these other ones checked. Get creative with it. Neat and colorful. Make sure that you're explaining your derivations. So really, it's just going to be anywhere from 0 to 10. I'll just say 10 is 100, 9 is 90, and so forth. Hey, Jack.
When did you say you wanted this shirt?
By Tuesday. By next Tuesday. So what is that, the 30th? So you have 1 week. That gives you through the weekend and also an additional day. Plenty of time before the 6 weeks is over to go ahead and do that. Now, this is not mine. I've done variations of this in the past. This I found off another resource. So the examples, these are not ones that I've had students turn in before. But here's one, and I apologize. This is just the picture that was provided. But you'll notice you got the main unit circle right here in the middle, and you can put it anywhere you want as long as it's the largest circle. And then you have the other 5, and they've chosen 1 point on each of those other circles. And you'll notice right next to it is going to be the explanation. Here's a little zoom in of that. They decided to go ahead and type it, and then I guess just glue it to the poster board. That's perfectly fine. You can go ahead and get creative with this. I like this one. This student went ahead and created pizza. Looks like we got some pepperoni, mushroom. I'm guessing that's anchovies. Yuck. Okay. But whatever. Now on this one, well, aren't anchovies little fish? Okay. But on this one, I have no idea what the student got on it. Based on the rubric, I would give this student an 80. Can anybody see what I took? Oh my God, for? Can anybody see why I would take off those 20 points? Yeah, you'll notice they did draw the largest unit circle, and they got the other 5, but there's no explanation for each of those. So that's one of the boxes I wouldn't be able to check. Now, you're probably not going to be able to see it from where you're at. The main unit circle, it has all the coordinates, it has all the degrees, but it does not have the radian measures. So I wouldn't be able to check that box either. I mean, it's a great project. I mean, it's very creative. But again, the rubric, that's what you're going to want to look at. Okay. This one here, this student went ahead and created like a little field of sunflowers. Okay. Looks great. Very creative. The main unit circle has all 3 parts. It's definitely the biggest circle. But on this one, I would give a 90. There you go. See, they did go ahead and provide something for each of the 5 circles, but this is what I was referring to a moment ago. I think this is probably overkill. You don't have to get that specific, but you want to do just a little more than what this person did. Okay. Again, still a great project, very creative, very colorful, but based on the rubric, I would not be able to check that 1 box for the explanation. Okay. I mean, you could, go ahead and relate this to anything out in the world, maybe a Ferris wheel, bike wheel, anything circular, just to, get a little creativity in there. But these are the guidelines that I'm looking for. All right. Remember, this is not required. This is only if you want to participate, if you want that extra credit. Okay. So if you decide not to, you'll just have the 2 tests. They'll count 15%. If you do this, then they'll count 10%. On each of those. Hey, Alex. Well, one of the boxes here, it is neat, colorful, and creative. Okay. So now remember, these are not mine. These came with the resource. Now, I've got a few other ones that I've had in the past. One person did Captain America's shield when I did my own version of this. That was pretty cool. One person did a minion where one of the eyes was the unit circle. I mean, just whatever you like. I think, do I still have it around here? There were some of those that I kept. I'd have to look for them. I got them someplace, but yeah. As long as I get it by the end of school on Tuesday, I mean, that's fine. You'll go ahead and just staple the rubric to the front of your poster, and there you go. Okay. So it shouldn't be a horrible project. I mean, definitely gives you more practice with the unit circle. So like I said, if you're interested, great. If not, that's great too. You don't have to do this. This is just for your benefit. Okay. And unless anybody has any questions, I think that's all I got. Hey. Oh, if not today, then probably tomorrow if you weren't here on Friday. Okay. All right. So I'll try to. I do want to go ahead and do my best to finish up the lesson today because what's due tomorrow? The homework's due tomorrow, yes. Okay. Well, all right. We've been talking about the unit circle quite a bit lately. Here is the full unit circle with all 16 of our points, everything filled in. But we need to make sure, especially for this exam, that we know these new ratios for the trig functions. Normally we say opposite, adjacent, hypotenuse, but now we're wanting to do it in terms of the vertical distance y, the horizontal distance r, or should be x. And what is r stand for anyway? The radius, and on the unit circle, that's what? Just 1. Okay, so how far did we get? I know we got the word problems done. Did we talk about this? We just started that? Okay. So there are 2, in fact, key concepts in the last part of your packet here that I'm just going to go ahead and mention very briefly. Really all they're doing is just kind of emphasizing ideas that we already know about. But let t be any real number on a number line, and let p, x, y be the point on t when the number line is wrapped onto the unit circle. Okay. Then the trig functions of t are as follows. So you have, the same ratios here. They're just using t. So the idea is that every point on the unit circle can be written in terms of cosine and sine. So let's say, for example, I'm just going to go ahead and pick a measure, let's say 42, because that's the answer to life, the universe, and everything. Okay. If you've not read those books, actually very good books, I recommend them. Okay. So this point right here, if I were to go ahead and rotate 42 degrees, well, I can easily find the coordinates of that point simply by saying cosine of 42 degrees, sine of 42 degrees. Okay. And the same is true for any radian or other degree measure that I have. The only time that will change is if it's not on the unit circle. And we've already seen some problems where we haven't been on the unit circle. Now, if you're not on the unit circle, you'll take the length of that radius times cosine, the length of the radius times sine. But you can still find the coordinates of any point you want on the circle. Okay, so that's all that's talking about right there. Okay, stuff we've already brought up. So let's get to this. So we have not done any of these? Okay, so let's go ahead and start with sine of 7 pi over 6. Now, this is actually what your happy minutes is going to be like on Friday. This is the first time where I'm going to have you create a triangle based off the reference angle, and then you're going to find me all 6 trig functions. But it's not coming up till Friday. Tomorrow is going to be just like today. I'm going to give you a triangle with a missing side. You find it, you find all 6 ratios. Okay, no problems. Now, here's the thing. We were talking about this last week. First, you want to go ahead and figure out, okay, what quadrant is my terminal side going to be in? Where will 7 pi over 6 put me? Okay, definitely the third, right? So if I start at 0 radians, here's pi over 2, here's pi, 3 pi over 2, and then we got 2 pi radians. Okay, well, 7/6 pi, that's 1 and 1/6 pi, right? So half a revolution, that is the 1 pi. But then I have to go an additional pi over 6 radians. So it's absolutely putting me in the third quadrant. Good, 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 good. So that's the first step. Now, once I have that, I'm going to create a right triangle with the x-axis. And remember, this is a big part of your test on Thursday. Okay, so we want to be practicing this. Now, we had to go an additional pi over 6 radians, right? But I personally like to go ahead and go back to degrees, especially when I'm working with these kind of triangles. So what is pi over 6 in degrees? That's 30, right? Hello. Hey. Satish. So this would be 30. This would be 60. There you go, sir. And now you've got that same 30, 60, 90 triangle that's been in the unit circle since we introduced it. Okay. Oh, does it say when convenient?
I don't know. It doesn't have.
Is that the nurse's pass?
Yeah.
I think she likes you to go as soon as they show up. Okay, so let's see. What's across from 30? It's always 1/2. What's across from 60? Square root of 3 over 2. That's a 2. And then we have a radius of 1. But always, always remember what quadrant you're in. Why do I bring that up? Okay, because here both x and y are negative. So that should be a negative square root of 3 over 2 and a negative 1/2. See, this is my x value, this is my y, and this is the r. Because if I want to go from this point, the origin, to this point on the circle, I got to go left and then down, right? So that's what 7 pi over 6 does. Okay. Use that angle measure to find the location of your terminal side and then create a right triangle. Once that's done, now look at your trig function. What does sine want? Sine just wants the y value. Well, what's the y value from my picture? That's it. So sine of a 7 pi over 6 is a negative 1/2. What would cosine of 7 pi over 6 be? Negative square root of 3 over 2. There you go. This is what your happy minutes is going to be like on Friday. I'm going to give you one of these. You'll have 5 minutes to create the triangle and then list all 6 trig functions. Okay. I'd say the worst part is just creating the triangle, because up to now, once you have the triangle, we know how to do the ratios, right? Okay. Hopefully we're feeling comfortable with that. Let's try another one. How about cosine of pi over 3? All right. Jane, what quadrant is pi over 3 going to place me in? Not 2. Okay. Ethan, can you help her out? Not the second quadrant. Remember, we want 1/3 pi. It had to be first because the 1/3 is less than 1/2, right? So it's got to be this guy right here. So we rotated pi over 3 degrees. So that's step 1. We figure out where the terminal side has to be. Now we use him to create a right triangle. But what's pi over 3 in degrees? That's 60. So here's my 30. Okay. So again, it's that same 30, 60, 90 right triangle. What's across from 30? 1/2. Across from 60? Square root of 3 over 2, and the radius is what? 1. So this is my x, this is the y, and this is the r. Okay. But what does cosine want? Cosine just wants the x value. So cosine of pi over 3 would be what? 1/2. What would sine of pi over 3 be? Square root of 3 over 2. This is what your happy minutes on Friday is going to be. You'll just find all 6 of those trig functions. Okay. This is a major part of your test. I'm going to give you just, a trig function with an angle measure and ask you to evaluate it for me. Okay. Questions? So the big part is just making sure, I would say indefinitely under a minute, can you get the triangle created? Okay, so why don't we go ahead and try that? tangent of 4 pi over 3. Now, if you really want to put yourself to the test, see if you can not only evaluate the trig function, but see how many others you can get. But right now, I'm just going to give you 1 minute. Let's see if you can identify what quadrant 4 pi over 3 will be in, and then create that right triangle, okay, based on your reference angle. Ready? Go. So 4 pi over 3. All right, that's 1 minute. So let's see how we did. How many people feel they successfully got the triangle? Okay, so maybe half. Let's see. Dylan, what quadrant am I in? Third. Okay, so 4 pi over 3, that's 1 and 1/3 pi, right? So half a revolution, there's the pi. And then I have to go an additional pi over 3. Okay. So that's my reference angle. Everybody's good? Okay. Now I'm going to create the right triangle, connect it to the x-axis perpendicular. But what is pi over 3 in degrees? That's 60. So there's the 60. There's the 30. Across from 30, again, is 1/2. Across from 60, square root of 3 over 2. Radius is 1. It's the same triangle, but both negative because we're in the third quadrant. There you go. So now I have my radius, x, and y. Okay. All of that comes from the angle measure. That's what 4 pi over 3 helped me do. Once you have that, now turn to the trig function. What does tangent want? Tangent always wants y over x. So y over x. So I'm going to take that y value, negative square root of 3 over 2, and I'm going to divide it by the x value, negative 1/2. What happens when you divide by a fraction? You multiply by its reciprocal. So negative square root of 3 over 2 times negative 2 over 1. 2's are going to cancel. The negatives are going to become positive. So it looks to me like the tangent of 4 pi over 3 will be the square root of 3. And does it make sense? We should have gotten a positive answer here. Remember, what was that phrase I taught you? All students take calculus. So the T in take stands for tangent. So we know we should be getting a positive answer. Okay. What would the sine of 4 pi over 3 be? Negative square root of 3 over 2. That's the y value. What would cosine of 4 pi over 3 be? Negative 1/2. That's the x value. And if you want the others, you can take the reciprocals or just take those ratios. Okay, how are we doing? Okay.
So for Friday, do we have to rationalize and simplify our answer?
Maybe. Okay. So I'm going to start out with 5 minutes on that one. Okay. All right. Good. Well, let's see what else we got. Find the exact value of secant of 270 degrees. Oh, yeah, you'll still write sine of the angle equals such and such. Yeah, we won't be putting theta because we'll actually have an angle measure on Friday. No, you don't have to put that. That's fine. Okay, so find the exact value of secant of 270. Okay, so first step. Where will 270 put me? Okay, it's a, what do we call that? It's a quadrantal. So right here, if I were to rotate 270 degrees, that is 3/4 of one revolution. Okay. But now, if it's a quadrantal, you won't be creating a right triangle because one of your side lengths is going to be 0. So just look at the ordered pair that we have there. What is on the negative y-axis? Remember, that was 0, -1, right? So I have an x, I have a y. Okay. What is, oh, so look at the wrong one. What does secant want? Remember, secant's ratio is r divided by x, right? Well, we're on the unit circle, so what's r? 1 over the x value, which is 0, but this one's undefined. Or you could put 0 with a slash through it. That would be perfectly fine. That's it. Quadrantals are even easier because you don't have to create the triangle. There's no triangle to create. Not all of them. Depends on what you want. Like, for example, what if I wanted the cosine of 270? Okay, well, what's the x value? 0. What would be the sine of 270? -1. You're just looking at the values of that ordered pair, the x and the y. And if you do have a ratio that involves r, like this one, r is just 1. Okay. Okay. Let's try this next one. Tangent of 7 pi over 6. Tangent of 7 pi over 6. So we want to try this one on our own again? Okay. Now let's do this. Let me give you 2 minutes. Let's see. Let's put ourselves to the test. Not only create the triangle, go ahead and find me sine and cosine for the same one. Now remember, on Friday you're going to be finding all 6, but baby steps. Okay. 2 minutes. And I would say definitely within the first minute, you need that triangle to be created. Oh, it's already 41. And you can even do the same thing on the homework. Numbers, let's see here, 9 through 16, 25 to 31, 43, 46. All of those are just evaluating the trig function. Okay. The only difference is on Friday, you'll be finding all 6 for that given angle. Okay, now I'm showing 50 seconds left. And remember, right now, we are only limiting ourselves to these 16 points. So if it's not a quadrantal, the triangle created has to have a reference angle of either 30, 60, or 45. Okay, and we know what those triangles are going to look like. Okay, I'd say the hardest part here is just figuring out what quadrant you got to be in. Okay, 10 seconds. Okay, so let's see here. Who haven't I talked to today? Kimberly, what quadrant would 7 pi over 6 put me in? It'd be the third, yes. Okay. So past pi, we have to rotate an additional pi over 6 radians. So what's pi over 6? That's 30. So this reference angle right here should be 30. There's 60. Across from 60, square root of 3 over 2. Across from 30, 1/2 with a radius of 1. But they're both negative because we're in the third quadrant. Okay. All of that comes from the angle measure you're given. Once that's done, then just look at the trig ratios. What does tangent want? He wants the y over the x. So this time I'm going to take the negative 1/2 and divide it by the negative square root of 3 over 2. Dividing by a fraction, you multiply by the reciprocal. So this is definitely going to give me a positive again. The 2's cancel. Looks like 1 over the square root of 3. And Connor asked about this a moment ago. Is it possible in one of these happy minutes that you may have to rationalize? Very much so. So what would this one be? Square root of 3 over 3. Now, how many people were able to get the triangle in under a minute? Okay, so we got more hands going up, so that's good. How many people got the answer within the time limit? Okay, very good, very good. All right. Well, this last key concept here, the rule actually says a function y equals f of t is periodic if there exists a positive real number c such that f of t plus c equals f of t for all values of t in the domain of f. Again, another one of those wonderful mathematical definitions. All this says is that at some point, all of these trig functions are going to begin repeating themselves. Okay, these guys are cyclic. After a certain revolution, you're just going to start getting the same answers over and over again. Let me show you. So here's the unit circle. Let's say I rotate to 30 degrees. I want sine of 30 degrees, right? So just looking at the unit circle, remember sine is the y value. What's the y value located at 30 degrees? 1/2, right? Okay. So sine of 30 degrees is just 1/2. Well, let's go ahead and give the first coterminal angle, the first positive. So what's 30 plus 360? 390. Okay, so let's test this. Sine of 30 degrees, we are correct, it's 1/2. But now let's go ahead and put in sine of 390 degrees. See, at some point, it's just going to go ahead and start giving you the same answers over and over again because you're rotating on the same circle. The direction doesn't matter. In fact, does anybody know sine and cosine at what point it's going to start repeating? If you don't, that's okay. We're going to be talking about it a lot when we graph them. It's 2 pi. After one revolution, it starts to repeat itself. Tangent's going to be different. He only goes pi radians before he starts to repeat. So he's not even a full revolution. He's only half a revolution. Okay, so let me get back over here. Now, I've got 46. So what problems, because I don't know if we're going to be able to hit all of them. Is there one in particular you want to get before we leave? We've got 9 pi over 4, negative 300, and 29 pi over 6. You want the last one? Okay, the last one, 29 pi over 6. So let's do this. Let me give you another minute. Within that minute, we should not only know where the terminal side is, but also have the triangle created. Is everybody ready? 1 minute for 29 pi over 6. Now remember, especially when you do this on your homework, I would encourage you not to use a calculator. You can use the calculator to help make sure you are correct, but you want to be able to do this without a calculator. "30 seconds. Okay, there's 1 minute. Okay, so let's see, who haven't I talked to today? How about Shayna? What quadrant would 29 pi over 6 put me in? It would be the second, yes. Here is pi over 2, pi, 3 pi over 2, 2 pi. We start at 0 radians. So 29/6 would be, what is a mixed number? 4 and 5/6 pi, right? So 4 That would be 1 pi, 2 pi, 3 pi, 4 pi. So we went 2 full revolutions. And then I want to go 5/6 pi. Yeah, so that would put me right over here. Very good. Let's say right there. Now, if after the 2 revolutions, if I went an additional 5/6 pi, then what is this reference angle going to be? What would give me 2 pi? 1/6 pi, right? But what's pi over 6 in degrees? So this one would be 30. This one would be 60. And again, you have that same triangle. So this one's going to be square root of 3 over 2. Across from 30 is 1/2. And then you have a radius of 1. And I'm missing something. Okay, negative only on the x, because the y is positive in quadrant 2. How many people got that triangle? Okay, so not bad. Not bad. It just takes a little bit of practice. Now, what does tangent want again? It wants y over x. So I'm going to take the y value, 1/2, and I'm going to divide it by the x value. Now, I'm going to go ahead and take a shortcut here. I know I'm going to divide by the negative square root of 3 over 2, so I'm just going to go ahead and multiply by negative 2 over the square root of 3. I'm just going to go ahead and multiply by the reciprocal. Okay. So let's see here. That 2's are going to cancel, so negative 1 over the square root of 3. We want to rationalize. So negative square root of 3 over 3. How are we doing? Okay. All right. Now, these others are on the website. They're already filled in, those notes. If you have any questions, come on in. We got a couple more mornings before the test. So, come on in if you have any questions. Let's go ahead and get those calculators back up on the front, please. That is all we got for today. There we go.